This mini lab is about speed measurement. In the lab, we'll be using a small DC motor powered by battery as the source. We're not going to measure the speed of the motor directly. Instead, we'll be using a rotary encoder as supplemental device. A flexible connector will be used to connect the encoder to the DC motor. So the encoder will be having exactly the same rotating speed as the motor. Two different ways will be used to measure the speed. The first one is the optical tach, and the second one is called a e-tach. This is a picture of the optical tach. It's a pretty easy to use device. In our case, there's a small reflective tab attached on the rotary encoder, so while the motor is running, the encoder is running at the same speed, and the optical tach will be pointing to the rotary encoder to get the speed. This is a short description about the e-tach. It's a relatively more complicated device compared to the optical one. You'll have to set up a number of switches correctly before using. This is a sample system setup. Basically, the motor and rotary encoder are on the top and e-tach2 DMM on the bottom. A close-up of the e-tach2 switch settings. For clarity, the optical tach is not included in this system. Now let's see how to take the measurements. While the motor is running, a DMM is connecting to the e-tach. The result from the e-tach will be showing as a DC voltage on the DMM. This value is around 4.3 volt. We'll talk about how to understand this number later on. Switching the measurement technique from e-tach to the optical tach. The optical tach is pointing to the rotary encoder, specifically the reflective tab on the rotary encoder, and the result is around 2.5 volt. After collecting the data, let's try to understand the results. The sensitivity of the optical tach is expected to be around 1 millivolt per RPM. The result from the optical tach is around 2.5 volt divided by its sensitivity is giving us 2500 RPM. So this is how much speed this 2.5 volts stands for. That was the optical tach. What about the e-tach? Based on the switch settings, the sensitivity of the e-tach is equal to 0.1 millivolt per hertz. And recall that the rotary encoder we're using in this mini lab has a CPR of 1024. So we use 4.3 divided by the sensitivity and divide by the rotary encoder CPR. This gives us the speed in 1 second. 1 minute is equal to 60 seconds, so times 60, this is about 2520 RPM. Here's the final result. Obviously, the two different technologies we used in this mini lab are giving us similar speed for the DC motor.